Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, we provide tutorials to learn about AWS services. We also create workshops and exercises and we publish them to our website aws-dojo.com, and you can use those workshops and exercises to get hands-on experience with various AWS services. Today, I am going to talk about how you can handle JSON data in Amazon Redshift. And then I have a demo to show you this capability in a live environment. So let's get started. So first thing first, let's try to understand what are we trying to solve here. So suppose you have deployed Amazon Redshift and you have created a data mart or a warehouse solution using Redshift. And now this Redshift is getting data from various sources. It might be getting data from social media platform or getting data from both relational or NoSQL or document based databases. It might be getting data from IoT devices or even getting data from REST APIs or even file-based systems. So there could be various different types of data sources from where data might be coming to Redshift, and then you want to query data on the Redshift for your analysis, reporting and dashboarding purposes. Now many of these sources which are publishing or sending data to Redshift, actually they send data in JSON format. So most of the data you gather from social media is in a JSON format. Many of the NoSQL or document based databases provide their document in a JSON format. IoT devices send their data in JSON format. REST API return their data in JSON format. You might have a file system where you are holding JSON documents and you want to publish them to Redshift. So there could be multiple data sources which are trying to send data to Redshift. And when you are bringing this JSON data to Redshift, the biggest question which comes to your mind is, first of all, how do I store this data into Redshift? So how do I store my JSON data into Redshift? And the second one is, how do I query this JSON data in the Redshift? And these are the two questions we are going to try to understand the various solutions available, and I'm going to focus on one solution more, which is a recent feature launched within Amazon Redshift. So primarily we are going to talk today that how do you store and query JSON data in Redshift. So there are various solutions to there are various ways you can solve this problem. One way of solving the problem is you convert your JSON document. So for instance, you're getting a JSON document from one of the data sources. In the ETL process where you are bringing data in Redshift, actually you parse the JSON document and convert into a tabular format and then store into Redshift. So simple, right? You have to read data from the JSON, convert into SQL, insert queries or update queries, and then put into Redshift. Yeah. And then in that case, since your data is in a tabular format within Redshift, you can simply use SQL query to query your data. So any SQL statement you can make into Redshift to query this JSON data, because your JSON data is no more a JSON data, it is now stored into a tabular format. This is a good approach, but obviously you can see here that in your ETL process you have to write some kind of business logic to parse the JSON document into a tabular format. Okay. So that's approach number one. Now approach number two could be and that you can use Redshift Spectrum, and I'm not going to again, Redshift Spectrum is a topic in itself, and I have actually created a different video where I have talked about this topic in greater detail in terms of how it works and what are different use cases. But in very simple terms, if I could explain it here as one of the potential solution is that you bring your JSON document and you put into Amazon S3, and then so you're not bringing your data to the Redshift. In fact, you're bringing the data to S3 and store is an object as a file in S3, and then use Redshift Spectrum to make that data available inside Redshift. And then in Redshift, you can make a SQL query, and using that SQL query, you can not only access data from the Redshift tables, but you can also access data from these JSON documents stored in S3. So this could be one good approach, and there, to be honest, I told you that this topic could be is a topic in itself, and I have a separate tutorials created for Redshift Spectrum to discuss what are different use cases when you should be using this approach. But yeah, this approach works fantastic. However, this approach might have some, if you are looking for a very high performance, then this approach might create a certain challenge because your data is not in Redshift, it is in S3, and through Spectrum it is made available. So you will not get the same level of performance what you get when all the data is in the Redshift itself. But this is a very good approach actually, where actually you don't need to do any parsing of the data. Your data can be stored in a natural format into S3 bucket, and then that S3 bucket based data can be then can be configured as a external schema inside Redshift, and then you can make SQL query to that S3 based JSON data. So this is also a good approach. However, if you're looking for same level of performance as you get within the Redshift table versus querying from the S3, then of course within the Redshift table you get a better performance than querying it from the S3 based data store. So that's the second approach. Now the third approach is where you simply bring your JSON data and store into Redshift. Yeah, so simple. No parsing, no S3 in between. You bring your JSON data and you store directly inside Redshift. And for that, actually, Redshift has come up with a new data type called super. So you can create a table, and in the table you can define certain columns as a super data types column, and those columns can store JSON document. Yeah, and then your query is similar to, like you can make SQL or particular query, and particular query you can use with these JSON documents. So the JSON documents or JSON string stored into table. So in this approach, actually your JSON data is stored inside Redshift table, and then you can use SQL particle query to query this data from the JSON document, just like you query any other column inside your table. Okay, and this is the third approach, and this is the approach which I'm going to talk in greater detail today. And this approach has been made possible because recently AWS announced that Redshift cluster can now handle semi-structured data, and this semi-structured handling of data feature is what made you store JSON into Redshift table, and then also able to query this JSON document using SQL and particle queries. So let's try to understand this approach in greater detail. So it is all about handling semi-structured data in Redshift. So how does the table definition look like? And that's where it is the simplest part, because if you want certain column to store JSON document, all you have to do is simply say that column as a super data type. So a table can have one or more different columns with super data type, and these columns can store your JSON document, JSON string. Very simple. Yeah. So table definition, one liner. If you want some column to store JSON document, simply make data type of that column as super. Yeah. So now assume that you have a customers table, and then you have got two columns, ID, which is small integer, and then we have details, which is a super data type. How do I insert my data into it? And actually you can use insert query to ingest or insert data into it. So your query might look like this. So for instance, here I'm saying that insert into customers, yeah, values, ID 1, and then since your details can have JSON documents, we are simply using this JSON.parse function, and then simply providing your JSON document under it, a JSON string under it. So when you insert this using this kind of query, your ID will hold the value of 1, and then your details will hold this whole JSON document as the value. And this JSON document can, like I'm showing a very simple key pair value based document here, but it could be a very complex hierarchical document, up to you. Yeah. So as I mentioned here, I'm showing an example over here. As a second example, you can see we are inserting in customers table some values. ID is 5, and here I have used one array with multiple pairs of key value pair to actually store the value. So again, all you have to do is simply use this JSON.parse function, and under that you simply provide your JSON string, which should be a valid JSON string, and then you can insert this JSON document or string into your super data type based column. Fair enough. So that's how you insert the data. Now this is one way of inserting the data, where you're using an insert is to insert into kind of a SQL query. But many people use copy data method especially when you're trying to insert large volume of data. And semi-structured data or JSON super column supports copying of the data as well. So your data could be in various format. It could be in a JSON format. It could be a CSV format. It could be a Parquet or ORC format. Your data which you're trying to copy through the copy command, it could be any of these formats, and then you can run this copy command to copy data from these files, or bulk copy data from these files to the table where it has a super data type based columns to store the JSON document. So you might, if you are trying to copy data, you might have to read a bit about, and I don't want to make this video super complicated by going deep into each of these things, but I want to cover it more from the capabilities point of view, what you can do. So the crux is that when you're trying to ingest data, insert into is SQL statement is one method, but you can also use copy command to copy data into it, and your source data from where you're trying to copy could be in any of the JSONs, CSV, ORC, or Parquet format. Okay, so copying of the data is also supported. So now that I can copy my data, I can create my table definition, I can copy my data. How do I query it? So let's take this example. So we have a customers table which has got two columns, and then in that you insert some values here. Now when you try to run the query, you can run query like the following. So like instance, look at this example here. So it's saying select ID, and ID is not a problem. ID is one of the columns over here. Then comes your details, dot name. So you can literally parse into a query into the JSON document. So when you're talking about details, here, the details is giving you access to the root of the JSON document, and after that you can use JSON parsing or query convention to reach out to the particular field or array or value inside the JSON document. So very simple. Details is giving me access to the root of the document, and after that I can simply say details.name. That will give me the value of John over here, because that's what you're trying to query. Okay, so and this is the beautiful part about using the super data type, because even if you're storing your JSON document inside your column, actually you can query directly inside the JSON document. It's not that you have to fetch the JSON document and do some kind of additional parsing in the JSON document to be able to query the data. In this case, you can look right inside the JSON document when you're trying to query data. Now, this details.name are looking into JSON document. You can not only do in the select query, but you can also use that into a where clause. So like in this case, I'm saying select star from customers where details.city. So your details.city is New York. So you can use this kind of, you can look into JSON document and you can put that into your where clause as well. So not only in the select columns, but also in the where clause. And the best part is, suppose you have got more than one tables which are using super data type, like customers and orders. And in that case, actually you can make join on those super data types as well. So here I'm saying customers table details column, and then cities inside JSON document is equal to orders.order detail into cities again inside the JSON document. So you can make this kind of join also, where you have two different tables, each having their own super data types, and you're looking to those JSON documents inside that super data type to make query. So query is very simple. It's as good as like you are, through that column name, you're finding the root of the JSON document, and then you are simply using the JSON parsing based syntaxes to look inside the JSON document for a particular value, whether you want to fetch that value into select fields, or you want to create where clause based on that. So that's how you can query the data. Now moving on, you can also create materialized view. So yeah, you can look into your JSON document as I mentioned earlier, but if you want to, for instance, create a materialized view on top of your JSON document. So suppose you created a table where you have got, suppose this is a table, it's saying customer orders, and some other table, and then you want to create a materialized view, which is kind of extracting the value of the JSON document. Suppose your JSON document has got like 50 fields, and then you say, I want to extract 10 of those fields or 5 of those fields and create a materialized view, and then use that materialized view for my query purposes. You can do that as well. So even support for materialized view is also available when you are using the super data type to store JSON document. And I'm going to show a demo on these things so you can see how exactly these queries work, just to give you an idea about. So moving on, so yeah, it supports materialized view. Now there are certain limitations and consideration you should be aware of. Now there are a couple of them, but some few considerations I want to highlight here, which you should be aware of. First one is that your super column cannot be a distribution or sort key. Yeah, so you cannot use super column for distribution and sort key, because your super column is not holding a value, but it's holding basically a JSON document or string. So it cannot be used for distribution or sorting purposes. The document size within your super data type should not be more than 1 MB. So your document should be maximum 1 MB. If you have more than 1 MB, then probably you might want to split your JSON document into multiple documents and then stored into multiple columns. It does not support inbound and outbound XML serialization. So super data type does not support XML serialization. And finally, there are certain casting limits which should be available. They are all well documented. Again, I don't want to dig further into that, because today, again, the purpose is to give a core message that your Redshift table can store a JSON document, and that JSON document you can query just like you query any field in your database table. So, having gone through some of these fundamentals, let's try to see a demo to understand how all these things work. So I'm going to now use certain SQL queries to create table, to query table, insert data, and those kind of things. These queries I'm also going to provide as one of the resource in the description box of my YouTube channel. So you can download this query by your own, and then you can run this in your own environment to play with super data type. So let's get started with the demo. So for the demo, what I have done here is that I have created a Redshift cluster, which is to keep the cost low. I have gone for a DC2 large, and it's a free tier configuration with single node. You can see over here. So I'm going to connect to the query editor. So let me log in to the database. So I simply connected to my database, and you can see here I have got a dev database, and then some trial, some test data is also loaded over here, which I'm not going to use today. So I will do first thing first. I'm going to first create a table which has a super data type. So let me copy paste it from my other screen. So you can see here, if I can increase my zoom in here a bit. So you can see here I'm creating a customers table which has got ID as a small integer and details as a super. I'm simply going to run this query. So this is going to create a table for me with super as a data type for the details column. So it is successfully created. Now I'm going to insert certain values into it. So I'm going to run a couple of insert queries over here. And you can see here I am inserting into customers table. The first column is ID, so I'm just keeping it 1, 2, 3, 4 like that. Then JSON.parse function, and then I'm providing a valid JSON document. And you can see here your JSON document. It's not that your JSON document has to be same structure for all the rows. Your JSON document could be different structure for different roles. Of course, when you're doing so, yeah, you have to be careful how you're querying your data. Generally, you will not like to have you can have depends. How you're getting data, but yeah, technically you have a flexibility to keep this schema open. You can keep any kind of schema per row, but generally we like to standardize, because then of course the purpose is to also able to make query, and if you don't have any standardization, then query might not look very good. So like in this case, I have done a small change. In one of the rows, I am simply adding one more field over here, but otherwise it's pretty much standard. But yeah, technically you can run any kind of query, any kind of JSON document, I mean. So if I run these statements, it's going to insert 4 rows for me, and these 4 rows will be inserted. Now if I try to query the data and say select star from customers, just to see how does my data look like, then it looks pretty simple and straightforward. If you see over here, it's simply storing my data as a JSON document over here. So let's try to run few queries. So for instance, let's see if I want to use a query like this, where I say, you know what, I'm interested in name, ID, and then in the details where my JSON document is stored, I want to extract just the name field, nothing more than that. if I try to run this query, it should give me the ID and the name from the JSON document, right? So if I come down over here, if I see my query results, you can see here it has extracted the name from my JSON document. Okay, now I can use a similar query in the where clause as well. So for instance, I'm saying give me all the rows where my details field and then age field in the JSON document and the value is less than or equal to 30. Yeah, just as a sample query. So I can use my JSON document based query in my where clause as well. So if I run this one, it should return all those rows where my okay, because I selected a part of it. So it's return all those rows to me where the age value in my JSON document is less than or equal to 30. So if I see the result now, gives me 2 rows over here, 3 and 4, where the age is 23 and 30. You can see here. Now, if I try to make a query on, for instance, you know that like in this example over here, in one of the rows, I added department as additional field, while this department is not a field in other rows. So what if I try to make query on that particular field? Will it break my query? The answer is no, because it's going to check whether the department as a field exists or not, first of all. If it does not exist, then it will simply ignore those rows where this field does not exist. But wherever this field exists, for those fields it will apply this filter criteria. So that's the beauty. That's the beauty of this feature, is that when you are having multiple JSON document with different schema, and if you try to make a query, and in that query you are mentioning certain field which is not present in all the document, it's not going to throw error for you. Those rows will be simply ignored because key does not exist there. Those fields, those keys do not exist there. But wherever those fields or key exist, those rows will be evaluated in the where clause and then, or even the select statement, and the results will be returned. So for instance, if I run this query here, it should show me 1 row and it will ignore 3 rows because those 3 rows in fact don't have department as one of the fields. Okay, so that was a few query with one of the tables. Now let me create one more table and add some more data into it so that we can see how the join works. So if I go here and copy some more things, few more things here. So you can see here I'm creating an orders table where I'm saying my customer name is varchar, order value is some decimal, order details is super, and then I'm inserting into orders. I simply put some name, some value for the order value, and then JSON.parse, and I'm putting kind of a JSON document over here. So let's create this table and insert these 2 rows. And then I would like to run a few queries between orders tables and my customers table. So my table is created and my rows are inserted now. Now let me run a query. And the first query which I want to run is where I'm saying that select customer ID from the customers and order value from the orders from tables customers and orders. And here I'm making joins. In orders, I'm taking a column customer name. So this is not a super type column. I think it's a varchar type column. But here in this case, customer details dot name, this is a super type data type. That means this value is coming right inside from JSON document. So with this query, I want to show you that when you're making the join, you can make a join between a JSON based value and a table column based value. Okay, so if I run this one, it should simply give me the result matching a JSON based name value with the customer name wherever it matches. Okay, so if I see the result over here, you can see, hey, yeah, it did found 1 row where the JSON document name was matching to the customer name. It simply returned the value. So you can make query between a JSON based JSON based value and a normal column based value, or a scalar value based scalar data type based value, a column. You can also do between JSON to JSON. Now I'm running a second query where I'm saying, okay, let's fetch customer IDs, customers.id from both customers and orders table, where in customers details JSON document, I'm trying to see the city value, and in orders order details table, I want to see the city value, and I'm trying to match both. So in this case, I'm looking into a JSON document into one table and a JSON document to second table, and I'm trying to make a join between them, okay, a condition between them. So if I run this query, it will also run, and this is just to demonstrate you that you can have a where clause where you put a condition based on the value in the JSON documents in more than one table. Okay, so you can see here it has returned me certain values where both city name matched between the order and the customer's JSON strings or documents. Now, finally, the last one is that you can also create materialized views. So I mentioned you that, yeah, you can make direct query like this, but sometime in order to enhance the performance, you might want to create a materialized view, which is kind of extracting certain field values from your JSON document and creating a separate view, and then you simply want to query that view, and that view is automatically updated, so you don't need to that gives you a performance. You can do that as well. So like in this case, what I'm saying is that from the customer table, details has got the JSON document, and I'm saying fetch the customer name, age, and city, and then simply create a view out of this query and name it customer master view. So this is going to create a materialized view, which is fetching data from the JSON document within a Redshift table. So if I run this query, it should create a materialized view for me. Now I can query the materialized view. So if I go and simply run a query saying give me select star from customer master view, and if I run this query, it should it should give me the value from the JSON document from and of course that is based on the view. So create a view like this as well in order to fetch data from the JSON document. It's not mandatory that you use only view, but yeah, if you want to improve the performance, then you might want to create a materialized view out of your JSON document values. So that was all for today, guys, to show you that how you can store and query JSON document into Redshift using a new feature in Redshift, which is all about handling semi-structured data in Redshift. I hope you like the video, and if you like the video, please click on the like button. Please subscribe to my channel. If you have any feedback, any comments, whether it is about the new content to be created or any mistake I did which you want to correct or fix, or if you have any question about any of the topic I have talked about, you can provide your comments in the YouTube channel comment section. I always look forward to interact with you, to get ideas from you, and then to present better content back to you. So that was all for today, guys. I promise to come back again in a week's time with another video. In the meantime, stay safe and have a nice day. Bye bye.